Dear students, welcome to the online class of SIELMAT Christian Higher Secondary School Mathematics Department. Small introduction. Mathematics Department is blessed with three faculties: Sir Biren Singh, Sir Ngaminlal, and myself, Sir Emmanuel Ramgailin, or you can just call me Sir Ngaya or RL. And as I've said, welcome to the online class, and I want to request the students to be serious in this online class. Whatever assignments or homeworks the teachers give you online, please make sure that you do them at home. Stay home and stay safe. So from nursery to class 10, we have been studying in different schools, taught by different teachers. We learn different processes, and we are molded in different environment. But my dear students, I would like to request you that in whatever situation you were, in whatever situation you start your career with, or in what schools, high schools, middle schools you are brought up with, does not matter. What matters most is what we want to be in the future. So class 11 and 12 is all about who you are going to be in life. That determines what you do in this 2 years time. So as we start this online class, as an introduction, I'd like to quote a sentence from George T. Doran. He's a renowned management book author, and he said an acronym, and in that acronym he said that the goals that we have in life should be smart, or in short we can say that we should have smart goals in life. Many students aspire to be an engineer. Many students aspire to become a doctor one day. Many students aspire to become a scientist. So if you really want to achieve the aim in life, it depends on what you do within this 2 years, class 11 and class 12. It's very important. So I want all of you to have a goal, to have an aim, and that aim and goals that you set for yourself should be very smart. So George T. Doran said that smart, the word smart, means S stands for, see, whenever you have goals, maybe to become an engineer or maybe to become a doctor, you should have a smart goal. And the word S, it should be specific. You should have a specific goal in life. Whatever you do, you should specify on that. You cannot just become 2 or 3 persons at a time. If you want to become a doctor, you should start preparing in that way. And if you want to become an engineer, you should start preparing in that way. And you should follow the process. So the word specific, you have to be very specific. Today we can't cover the whole of mathematics syllabus in one period, because that would be impossible. But if we specifically take the topic-wise, subject-wise, and topic-wise, we'll be able to be specific in our goals. And M, measurable. The goals that you have set, and chasing that goal, as you strive toward that goal, it should be measurable. Whatever you do, the steps that you take should be measurable. Like for instance, you have to spend 2 hours, maybe you need to spend 2 hours studying mathematics, and the next hour maybe physics, and the next hour maybe biology and other subjects, chemistry and other subjects. So anything that you do should be a measurable thing so that you achieve your goals. If attainable, aim for something which is attainable. You cannot attempt, or you cannot overnight, you cannot try to become a doctor, or you cannot aim maybe tomorrow I'll go to the moon. That's impossible, because one day you might go to moon as an astronaut, but that is not possible right now. So what is possible now is, whatever classes I take today, let me know it tonight. The next day, let me know the portion of the day. So those are aims which are attainable. And R stands for realistic. As a boy, you cannot aim to become a girl. Otherwise, it will be a problem. So do something which is realistic. And T, time bound. Everything should be bounded with time. You cannot spend the whole 3 years studying class 11, or you cannot spend 3 to 4 years repeating class 12. That means you will be a failure. So I want you to have goals which are specific, measurable, attainable, realistic, and should be time-bound goals. So this would be very helpful as we start our new journey in life, from the high school to the higher secondary. So I want you to have set goals in life so that you can attain them, so that you can march toward that goal, and in future you can be someone in life where you can help the society, and you will be an important person in society in future. And as I've mentioned in the beginning, in this first online class, I like to start with chapter 16, probability. In class 11, probability is in chapter 16, and combined with statistics, it carries combined with statistics carries 12 marks, and the marks you can expect from this is, you can expect an essay from probability, or you can expect essay from statistics. So this is a very important chapter where essays will be asked. So first concept that we have to be clear is, what is probability? What is probability? So probability in short is the chance or the probability of an event to occur or not to occur. If you look at the present situation, let me ask you this question. What is the probability that the schools will reopen as usual next week? So maybe 90% or 99.9% of you might say no, it will not be open by next week. So let us assume that no, 90% says no. Our schools, the colleges, that education system or educational institutions will not open by next week due to COVID-19 pandemic. But 10% says yes. Maybe the 10% believes that maybe the government would make new statement tomorrow or day after tomorrow within this week, and all the institutions be clean up. Any institutions which are being used as quarantine center will be disinfected, and gradually by next week the school will be open. That's a probability. So this 90%, if we convert it into the usual arithmetic, percent means divided by 100, and 10% means 10 by 100, and if you solve this, 9, you get 9 by 10, which is 0.9, and this 1 by 10, which is 0.1. So if you look at these two figures, 0.9 and 0.1, these two figures, 0.9 and 0.1, are the probabilities that the schools will reopen or will not reopen. So 90% of the students believe that the school will not be reopened, and the probability wise it is 0.9. And school will reopen, 10% says yes, it will be reopened by next week, and if we see in probability it is 0.1. So in day-to-day life we have always encountered with probability, regardless of whether we notice it or not. So we are clear that percentage wise is also probability. So looking at the sky, if I say there is no chance that it will rain, so let's say 0%. So what does 0% mean? 0% means no chance. There is no chance that it will rain because the sun is shining so brightly. Maybe one fine evening I look at the sky and it's very cloudy, so I say, okay, 100% it will rain. What does it mean? It means that 100% means 1. So 100% 1 means 1 is called it total probability. So when I say 1, it means in probability, when I say 1, it means 100%. So that means any probability will always be between 0 to 1. And it cannot be negative and it cannot be larger than 1. So that makes us clear what probability is. Now I will come to the exact definition of probability. Now in high school we have learned that probability means probability equal to number of favorable outcomes divided by total number of outcomes. So I indicate this P by capital P, and this number as NF, and this number as total. So this is the mathematical definition of probability. Now what is probability? It means it's a ratio of favorable outcome to total outcome of an event. And in class 11 we have to take care of small definitions which are given in the textbook. So I'll come to that now. Now that we know what is probability, I would like to explain to you certain small definitions which we must know as a student of class 11. Number 1. What is a random experiment? A random experiment is an experiment in which the outcome of the experiment cannot be determined before the result is out. That means you cannot foretell the answer correctly. Let me take an example. You toss a coin. Toss a coin. So we have coin. I have a coin here. So the coin always have two faces. So when I toss this coin, it might end up facing the head or the tail. So when you toss a 1 rupee coin, and I'll come to the second definition, which is sample space. Now what is a sample space? Sample space is the collection of all events of a random experiment. Whatever outcome that is possible out of the random experiment, the collection of all those outcomes is called a sample space. Now when I write the sample space 4, I denoted it by S, capital S. When I write the sample space, I use a second bracket. So when I consider this tossing a coin once, and the possible answers are, it might be head, comma, it might be tail. So I have only two options. The coin might be a head or tail. So only two options. So this is called a sample space. Now I would like to write this way so that we can understand it clearly. So what does N indicates? Let me use an implied step. This sample space implies that number of sample space is 2. So how many outcomes do we have? 2. Now I will come to the definition of probability. Now what is the probability that a head comes up when you toss a coin once? What is the probability that when you toss a coin once, that a head comes up? So what is the probability that a head comes up? The probability is, we already know that probability is number of favorable outcome by number of total outcomes. So what is the favorable? Head is the favorable. So how many heads do we have in the sample space? Only 1. So I write as 1. What is the total? Total we have 2. So 2. So the probability that a head comes up when you toss a coin once is 1 by 2, which is 0.5. So this is the probability of a head to appear when you toss a coin once. So in the same way, the probability for a tail to come up is also 1 by 2, which is 0.5. So when you add up these two, 0.5 and 1, you get 1. So this means that when you toss a coin once, to get a head and a tail are two mutually exclusive events. That means when you add these two probabilities, and when the sum is 1, that means there are no other events within this sample space or within this random experiment. So 1 indicates that this whole thing happens mutually exclusively within themselves. So these two concepts, random experiment and sample space, are very, very important. Now let us solve some problems from the exercises. If you see exercise 16.1, question number 1 reads like this: a coin is tossed 3 times. A coin is tossed 3 times. So it says write the sample space. So let us try to write sample space when a coin is tossed 3 times. So the solution, okay, the question is a coin is tossed 3 times. Write the sample space. The solution is sample space is, so when you toss the coin, this can be head or this can be tail. So this is tossed 3 times. I write 3 coins. This can be either head or tail, head or tail, head or tail. So when I toss a coin 3 times, this is the first result, the second result, and the third result. So in the first, it can be head. So with this, it has a pair. It can also be head, and it can also be head. So let me write that. Head. Next, keeping in mind this head might be tail, and then it might be head, and it goes on. So head, tail, head, and it goes on. So different ways of doing like this. Now I will tell you the trick of writing this. So you concentrate here, head, 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 and I want you to put one tail in each and every position. So put a tail here and do not change the other head's position. So tail, head, head, and move this tail. So this tail moves here, tail, head, and this tail moves to the next. Now you see this is 3 heads and 1 tail have taken 1 position, second position, and third position. So complete. 2 heads and a tail is complete here. And the next, you take tail, 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 and you put a head and a 2 tail, and you start moving this. So tail, head, tail, 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 head, and you close this right off. Now, if you see number of sample space, you have 8. So this is the answer. So when you toss a coin 3 times, the total number of events or number of sample space that will occur is 8. So this is the answer for first question. And when you see the second question, a die is thrown 2 times. A die is thrown 2 times. In the second question, a die is thrown 2 times. So solution, sample space. What is a die? All of us would like to play Ludo, I guess so. So Ludo is a die. So when you see a die, we have a cube-like structure like this, which have number from 1 to 6. So the possible are 3, 4, 5, 6. In the same way, die is thrown 2 times. So you obviously have 2 answers for this. So 1 to 6, 1, 2, 3, 4, 5, 6. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and it keeps on going for the rest, like that. So let us follow this and write 1. Since it is 2 times, it will have 1 and 1. Next we have comma 1 and 2, 1 and 3, and it goes up to 1 and 6. Next you have 2 and 1, 2 and 2, and it goes on up to 2 and 6. And this will go on up to 6, 1, 6, 2, up to 6, 6. So this is how you write the sample space. So this implies that how many sample space are here, we will see it. So this is a trick to know the number of sample space. The trick is very simple. What are the possible outcomes that you have here? Keep that in mind. 6 possible outcomes. So the formula is there are 6 possible outcomes. And how many times do you have to throw this? 2 times. So 6 squared. The general formula being x raised to n. Or you don't have to memorize the formula. Just remember number of possibilities multiplied by number of times. The experiment is being done. So 6 into 6, 2 times 36. So there will be 36 events going on here. So every line has 6, and there are 6 rows and 6 columns. You have 6 into 6, you have 36 items here. So which is exactly shown in this formula. So 36 items. So this is how we solve sample space. So I would like to give you homework. So dear students, homework would be exercise 16.1, question number 4 and question number 5. I think this will go. And let us move to question number 16. In question number